Presentation, I want to highlight some of the natural language processing tools used by IBM Watson. And again, they are all kind of being used for information retrieval. So to a certain degree, we're still talking about information retrieval. So here are some of the tools that they used. They used an English slot grammar parser. That's some technology that was developed by IBM, or Parser was developed by IBM. It's very similar to what we have seen when we talked about the Stanford parser. Predicate argument structure, a simplified parse tree. So sometimes you just want to get the gist of the sentence. So you look at predicate, subject, predicate, object, just so like distill things down to important things. For example, you might have a sentence in, I don't know the exact date, 1921, Albert Einstein won the Nobel Prize for his work on the photoelectric effect. Lots of words. Maybe you just want to distill it down that Einstein won a prize or won a prize. So that's kind of like what we do over there. Named entity detection, we already talked about that. And we'll see examples about all these things here in a minute. Anaphora resolution, temporal normalization, and temporal arithmetic. And we'll see that in the next presentation when we talk about reasoning. Semantic relation detection through pattern-based, so that's rule-based to a certain degree, as well as statistical, where you may not have a rule, but there's some other ways to determine that, yeah, these two words are kind of similar. We have seen how we would do that with neural networks, but there are other ways of doing that. So let's have a look at some of this stuff. Here is the pipeline for their ESG parser. There's some text. We do similar stuff as the Stanford parser does, tokenization. We'll do lexical analysis. We look at the post processor, multi-word processor, and then we actually have the parser over here. And so we might get something like this. What can we do for you? And so they have a root somewhere over here, which is can. A lot of times verb phrases are the important things that we're interested in. We have direct objects, I think indirect objects too. So just their parser, but other parsers that work on the same principle. Here's a different sentence. This little bear of children's lit was named for the London locale in which he was found. So just a parse tree, big deal. It's very, very similar to what other parse trees are doing. Named entity detection. So what we do over here is just like with the Stanford parser, we still like try to figure things out. So over here we're talking about an element. Notice I go a little bit beyond it. This is a nominal element. This is the category of the element. Hundreds of entity types, people, nations, cities, books, used in many components of Watson because it's so crucial, right? I mean, it's just about as crucial as a lexical answer type. So if we know what we need to look for, that is very, very, very helpful. Anaphora resolution, Vasco da Gama commanded a Portuguese ship. He sailed more than 6,000 miles over open ocean. So who is he referring to? Vasco da Gama, right? So very, very helpful. Relation extraction, sort of similar to what I mentioned a little bit ago, but a little bit more general. The New Jersey Devils have signed Adam Larson to a 3-year entry-level contract. So Adam Larson now works for the New Jersey Devils. So that's things that we want to understand, and if you can, pre-process it and put it in a database. Here are some of the databases that already had relations in them, DBpedia, and others. So you can use Wikipedia, obviously, to extract relationships also. As I mentioned, they used a system over here to extract yet more relationships or yet more nuggets out of free-form text. Now again, these are sort of like the entries that you always find in the upper right corner of Wikipedia, which tells you critical information about a person, when they were born, when they died, where they lived, citizenship, those sorts of things that a lot of times are questions that Jeopardy is interested in. Where do we use NLP, or where does IBM Watson use NLP? In several spots, certainly when it comes to the question analysis, lexical answer type analysis, and the primary search, deep evidence scoring. Again, they use many other tools. They use databases, but they also have text that they downloaded that they still search. So going back a little bit to lexical answer type, the sort of stuff that they're interested in. Here's a category, poets and poetry. He was a bank clerk in the Yukon before he published Songs of a Sourdough in 1907. So they identify certain components. So the focus is he, right? That's what the question is asking about. And so the lexical answer type then is he, or the information that goes to the lexical answer type is he, and then we can sort of like figure out a few other things about that thing. Well, first of all, it's a male person, but based on the sentence, we also know that they're a clerk, and based on the category, that person must be a poet. So those are three lexical answer types that they're looking for. Then they extract some information. There are some entities, again named entity recognition, Songs of a Sourdough. Again, it's not that hard to do a database lookup and figure that that's a book title. And then 1907, Yukon, things like that. Relations, somebody published, or he published a book, this particular book, Songs of a Sourdough. And so going back to then to good engineering, they identified three possible categories of question: factoid, definition, and multiple choice. So that's what they, and eventually they settled on factoid. So just really brilliant to sort of like realize, what are we looking for? Not just sort of like blindly processing a question and see whether we can match it up to some answers. Oops. So passage scoring, that's kind of the hard part, right? I mean, you can always download databases and use them. But there's so much more information that is not contained in those databases that you can download. So you kind of have to create your own database, and they did that to a certain degree. They processed many of the documents that they downloaded and put them in a database. But they still did some live searching of passages or processing of passages. And so there are a couple of techniques that they use, and we're going to look at them here in a moment. Among others, passage term matching, textual alignment, skip bigrams, LFACS and LSAs, and string kernels. So let's have a look at that. This is a really nice example, and we'll sort of like stick with it here for this presentation and for the next. So here is a clue. In May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. Okay, so obviously they're looking for a person. Now here's a sentence that we might find in Wikipedia. On the 27th of May, 1498, Vasco da Gama arrived in Kapat Beach. So, so what are some of the terms? They're celebrated. There's May 1898. There's the 400th anniversary. Portugal arrived. There's an explorer in India, and then there is a date. We will talk about this later, but notice that the date over here is not the same date as this one over here. And so they do some temporal reasoning. They realize if there was a 400th anniversary, then they need to go back by 400. And that's what they did over here. They know it's May. They don't know the day of May. And so when you process this one over here, you know that there's something called arrived in Kapat Beach. Vasco da Gama, and then this date over here. So then they indicate how strong those matches are. And so again, this is just simply based on the passage term matching. So the only thing that matches strongly is really in. And but notice that arrival, arrived, we talked about lemmas the other day. That's pretty close, right? I mean, the date, again, as us looking at this thing, I mean, that's extremely close. If you do some geospatial reasoning, and we'll talk about that in the next presentation, you kind of realize that, oh yeah, certainly at that time, this was part of India. It probably still is, I don't know. And then this one doesn't match at all, right? It matches, if we look it up, probably that it's a he and explorer. But at this point in time, we just do passage term matching. We sort of like say, okay, are these two related? Textual alignment. So same sort of processing of the sentences. And so notice that we had in before, and we still have in as a strong match. But we now also know that Vasco da Gama is an explorer. The 4th anniversary, so we're putting things together, matches with this one. Arrival and arrived matches with this one. India and this one matches with that one. So we're now sort of like aligning text rather than sort of like saying, oh, these things sort of like match. So we add some structure to this thing. Skip bigrams. Bigrams are typically on words, but they can also be on characters. So if it's a bigram, you always take, it's a sliding window of 2 words. On the 27th of May 1498. And they're pretty good at sort of like determining the flavor of the text. They can be used for authorship attribution really well because, again, they sort of like they really are very good at capturing the writing style of people. A senior thesis student several years ago used skip bigrams to prove that he sort of trained it on Shakespeare's writing. And in one of his writings, there are 2 paragraphs that experts sort of like disputed were written by him. And he was able to prove that, yes, those experts are correct, that it wasn't written by him because the writing style is just different. So skip bigrams, you get to skip a word. So we have on the as well as on 27th. We have the 27th as well as the of. So you get to skip one. And so this is kind of like what we get over here from this skip bigram. We get some, again, we sort of like figure out some internal structure over here. Okay. Logical form answer candidate score. So notice what we do over here is we're looking at the parse trees or the graph. So something over here is they want to find out who invented the telephone. And so maybe it says he invented the telephone or something like that. Then suppose we have a sentence where we see that Bell invented the telephone. Again, imagine that the sentence is more complex and the clue is more complex, but so like distills down to these things, subject, predicate, object. And so over here, based on these 2 parse trees, we kind of see that things match actually very well. We have invented, we have telephone, which is the object. Invented is the root of this graph. And then the subject is Bell in this example and question mark in this one example. So we have good reason to believe that Bell invented the telephone. Here is a sentence, Bell invented the telephone and Einstein discovered relativity. And so the question is, did Einstein invent the telephone? And so let's see whether we can match this stuff. Bell invented the telephone and Einstein discovered relativity. So as you can tell, no, well, we have evidence for this one over here that Bell invented the telephone. So we do the subgraph matching, but we don't have this one over here. Let's see. So going back now to the example about Vasco da Gama, we now see much more matching based on parsing the structure. And so we now see that We have a subject in here and a subject. We know that Vasco da Gama is the subject of landed. We have a match between arrival and landed. We'll look at that one in the next presentation. That's statistical paraphrasing, I believe. So notice that we have temporal links. I believe that's what it is. Object, prep, subject. So once we sort of like take structure into consideration, it's a much stronger match. So that's kind of really helpful. Let's see. Yeah, I think we already talked about this one here. In later years, who invented the telephone? So here's a sentence. In later years, Bell described the invention of the telephone and linked it to his dreaming place. So, so it really talks about he described the invention of the telephone. So it doesn't really say that he invented the telephone. I mean, it could have been, you know, substitute this one here like Einstein, right? Einstein described the invention of the telephone. So this one doesn't directly state this thing. So also, you know, those are things that that you have to be careful about when you match those subgraphs. Alrighty, folks, that's it for this one. I'll talk to you later.